Before a protein is made, and before tRNA even enters the ribosome with an amino acid, there's one critical step that decides whether the protein will be correct or completely wrong. This step is called aminoacylation, or charging of tRNA. In this process, an amino acid is attached to its specific tRNA by an enzyme called aminoacyl tRNA synthetase. Each amino acid has its own enzyme, so there are 20 different aminoacyl tRNA synthetases, each highly specific. These enzymes have 3 main binding sites, one for the amino acid, one for ATP, and one for the tRNA. This setup ensures that the correct amino acid, ATP, and matching tRNA all come together in the right position for the reaction. The aminoacylation process occurs in 2 main steps. First, the amino acid reacts with ATP in the presence of the enzyme. Here, the carboxyl group of the amino acid interacts with ATP, forming an activated intermediate called aminoacyl AMP, while releasing pyrophosphate. In the second step, the correct tRNA binds to the enzyme. At the 3' end of tRNA, there is a conserved CCA sequence, and the terminal adenosine has 2 hydroxyl groups, one on 2' carbon and another on 3' carbon. The activated amino acid is transferred to one of these hydroxyl groups, forming an ester bond and releasing adenosine monophosphate, or AMP. This results in a charged tRNA ready to participate in protein synthesis at the ribosome. Based on where these enzymes attach amino acid on the tRNA, aminoacyl tRNA synthetases are divided into 2 major classes. Class 1 enzymes attach the amino acid to the 2' OH group of the terminal adenosine and approach the tRNA from the minor groove. Class 2 enzymes attach the amino acid directly to the 3' OH group and approach from the major groove. In many cases, when attachment initially occurs at the 2' OH group, the amino acid is later shifted to the 3' OH group through a process called transesterification. A key feature of many aminoacyl tRNA synthetases is their proofreading or editing function. If the wrong amino acid is attached, the enzyme can recognize and remove it, preventing errors. This ensures extremely high accuracy in protein synthesis, because even a single mistake at this step can lead to incorporation of the wrong amino acid, producing a faulty or non-functional protein. So, before translation even begins, aminoacyl tRNA synthetases act as the quality control checkpoint of protein synthesis.